uniform meter rule weighing 0.5 meters is to be pivoted on a knife edge at the 30 cm mark. Where will a force of 2 Newton be placed from the pivot to balance the meter rule? Okay, they say that a meter rule, we are going to create a diagram for this. A meter rule, this is a meter rule, forget my diagram, weighing 0.5 Newton. Since the meter rule is a uniform meter rule, its balance point is going to be, or its weight is going to be concentrated at the midpoint of the rule, since it is a uniform meter rule. Okay, so this 0.5 Newton is at the midpoint of the rule. Remember, a meter rule is 100 centimeter rule, so it has from here to here to be 50 cm, and from that point also to this other point as 50 centimeter. Okay, is pivoted on a knife edge at the 30 cm mark. So the pivot is being placed here. If the pivot is being placed here, this is the 30 cm mark. Okay, if the pivot is being placed here, the tendency is that more of the weight of this rule will be on the right hand side, and so the rule, the tendency is that the rule will fall to the right. So the question now is, where will a force of 2 Newton be placed so that this rule will not fall to the right? It will be balanced. The implication is that the force will be placed here. A force will be placed in this place so that it will pull it back, because like I said, since the balance point of this rule, as it is a uniform meter rule, is at its midpoint, but we didn't place the pivot at its midpoint. We placed it at 30 cm from the left end. That means we have more of the mass at the right end, and the tendency is that it will fall to the right. So we are going to place a 2 Newton mass, as the question expects us to do, at the left hand side. That's where we'll place a 2 Newton force, so that it will balance the rule. But where exactly will that force be placed? That is what we want to find out. So if from this point to where the pivot is 30 cm, and from that same point to where the balance point of the rule is 50 cm, it means that from the pivot to the balance point of the rule will now be 20. That is 50 minus 30. And then we want to now get the distance of this, where we are going to place this newtons, so that we'll find the distance to the pivot. Let's call it x. And then the distance of this other force to the pivot, which is the width of the rule, is 20 centimeter. So we are going to see from the rule of moment that the sum of clockwise moments equals sum of anti-clockwise moments. Okay, sum of clockwise moments equal to the sum of anti-clockwise moments, and these are the only two forces acting on this rule. So the clockwise moment is going to be this force times the distance of the force to the pivot, which is 0.5 Newton times 20 centimeters times 20 centimeters, while the anti-clockwise moment is going to be the force times the anti-clockwise distance. You see how it will go in anti-clockwise, so it's going to be 2 Newton times x. Okay, and we have to find the x. Of course, 0.5 times 20 will give us 10 Newton centimeter, and then 2 Newton times x. We then divide both sides by 2 Newton. Divide this by 2 Newton. This 2 Newton will cancel this 2 Newton. Newton here will cancel Newton, and 2 divided 10 will give us 5 centimeter equals x. So it means that the x equals 5 centimeters. It means that this 2 Newton is going to be placed 5 centimeters away from the pivot to the left in order for this rule to be balanced. Or we can say here is 5 centimeter, and this from that point to the pivot is 30 centimeter. Then we can say that the 2 Newton is placed 25 centimeter from the left end. 25 centimeter from the left end, as the pivot is 30 centimeter from the left end. So that is how we calculate that. Okay, that is about this question. One other question we are going to look at is a seesaw which is perfectly in balance. The weight of the people sitting on it are 50 kg, skg, and 15 kg as shown. The seat at distance of 1.5, 1.5, and 2 meters from the pivot respectively. Find the value of x. This is a Jamb question where you see these three men, I presume, or three persons sitting on the seesaw at different positions. Two are seated in one direction to the right, and one is seated to the left, and they said that this seesaw is balanced. So you can see their distances 1.5 meters, 1.5 meters, and 2 meters away. So in order to get that, remember, weight of a body acts downward. So these their weights are downward forces. Okay, you can see that if you take the moment about this point, okay, let's call this point A. If we take a moment about point A, the clockwise moment, this one will go clockwise, this one will also go clockwise, but this one will go anti-clockwise. So the sum of the clockwise moments, the first clockwise moment is the weight, the mass. Let's use mass, since weight is mass times gravity, and all of them will have the same gravity and we cancel out. So we are going to say the mass here times the distance, which is x times 1.5 meters for the first body. Okay, and the second body we are going to have plus 15 times the distance of the second body from the pivot, which we can see as 2 meters, times 2. Okay, that is the clockwise moment. Then in the anti-clockwise moment, you can see the force in the anti-clockwise moment. 50 kg is the mass of the body, and the distance from the pivot is 1.5 in anti-clockwise direction. So we are going to have 50 times 1.5. okay, if we simplify, this one is going to be 1.5x. Let's leave the unit. 1.5x plus 15 times 2, you have 30, equals 50 times 1.5. We have 75. Then we'll collect like terms. 1.5x equals 75 minus 30. Therefore, 1.5x equals 45. We divide both sides by 1.5. So if we divide this by 1.5, divide this by 1.5, this will cancel this, and then our x will be equal to 30 kilograms. So that is the magnitude of the mass of that body that is labeled x. So this is how this question is solved. See you in the next class. God bless you.